Hey, this is Horner, and this is the last four problems, number 12 through 15, for the constant velocity motion problem exercise set. Sandusky runs a 5K race, or a 5,000 meter race, in the beautiful city of Cleveland. Unfortunately for Sandusky, there's a lot of people in the race, and she has to start several meters behind the start line. So she runs at a pace of 5 meters per second. We know that that is her velocity. So her velocity here is 5 meters per second, and the change in time is 1,015 seconds. So she runs pretty quickly here. They want to know what position does she start? So we're looking for the initial position if she ends the race XF at the 5,000 meter mark. So now we can use our equation again. XF is equal to V times the change in time plus XI, and we're looking for XI. So let's plug everything in. 5,000 meters is equal to velocity, which is 5, times our time, which is 1015. And I know I left the unit in here. I'm going to go ahead and get rid of that. There we go. This will make this a little bit easier. And then we're going to add to that xi. I need to go ahead and multiply this through. And when I multiply the number through here, I'm going to end up with 5,000 is equal to 5 times 5 is 25, 5 and 2 is 7, 0, so it would be 5,075 plus xi. And now I need to subtract 5075 from both sides. And when I do that, I'm going to get negative 75 meters is equal to my initial position. Notice that it is negative, and that's because this is the, this is the start. That'll work out better. This is the finish, and we know from here to here is 5,000. She actually had to start at this point, which was 75 meters or negative 75 meters. That's the position for where she started. So she had to run an extra 75 meters in this race. For the next question, which is number 13, the world speed record on water was set in 1978 by Ken Warby of Blowering Dam, Australia. He drove his motorboat a distance of 1,000 meters, and they took him 7.045 seconds, so they want to know how fast he was moving. We know that the change in position here is equal to 1,000 meters. We know that the change in time, was 7.045 seconds. So we want to find out what is this person's velocity if we say that he drove in a straight line from one place to the other. We know that the change in position then is just equal to the velocity times that change in time. Our velocity here, we want to solve for velocity, so velocity is just the change in position over the change in time. Change in position is 1,000 meters, change in time is 7.045 seconds, and if you divide those two, you get 141.9 meters per second. If you remember on the board up front, the whiteboard, we have this equation written down. So you can really just start with it. You don't need to do this unless you're thinking about our equation xf is equal to v times t plus xi. And this would be delta t. All right, let's go ahead and take a look at the next one, second to last. The number 14, the Kentucky Derby. The first leg of the horse racing's Triple Crown was won on May 5th, 2007 by Street Sense. Time here was 122.2 seconds. The race covers this many meters. They want to know what is this average speed in meters per second. So this one we're going to say we're actually looking at speed. And we're looking at speed because remember that track is circular. And if we did velocity, if you end up where you start, then you don't really have any displacement at all. So speed here, average, is equal to distance that he traveled divided by the time that he travels. So our distance here was 2011.25 meters, and we know the time was 122.2 seconds. So when you divide those two, you end up with 16.46 meters per second. This one has 5 sig figs in it. This one has 4. So let's just go ahead and just use 4. Just have to be reasonable when we do our answer. And that is the average speed for the horse. Finally, the last one. This one's a little different. the torpedo is fired from a submarine. So what I'm going to do is I'm going to draw the best submarine that I can. So there's the periscope on top, and then here's the submarine here, and we fire the torpedo out of the submarine, and it comes out and it hits a ship. So the ship, here, let's put a water line. Water line. There's the water line, and then we know that the ship is above water, but it hits the hull of the ship to sink the ship. So there's our ship. Okay, cool. From here to here there is a distance of, or a change in position here, of 2,000 meters. And at first the torpedo moves in this direction with a speed. So here, oops, our speed, S-P-E-E-D, is equal to 20 meters per second. Then it says that the sound of the impact is heard 101.4 seconds after the torpedo was fired. So let's think about this. The sound, and let's even change color because I think that'll help. Let's make sound blue. Sound is blue. There will be time for the torpedo to go all the way across, and then sound once it explodes. Okay, so we've got this explosion here, like that, and then the sound travels back through the water to the submarine. And so we want to know, what is the speed of sound? Okay, how fast is sound traveling? All right, so to do that, first thing we need to do is we've got to figure out, since the torpedo has to travel, let's figure out how long it takes that torpedo to travel. So the speed of the torpedo is 20 meters per second. We know it goes 2,000 meters. So the speed, speed, I keep doing that same thing, speed is equal to the change in position. So we're going to say this is just the distance divided by the time. And we want to know how long it takes. So time is equal to the distance over the speed. Our distance from the ship, from the torpedo, to the ship is 2,000 meters, and the speed is 20 meters per second. So if I solve for that time, we find out that it takes 100 seconds for it to get there. The total time is 101.4 seconds. So they fire it, it takes 100 seconds for the torpedo to move this way. So, and then it takes 101.4 seconds for them to finally hear the sound of the boom come back to the ship. Because of that, we're going to say 101.4, that's the total time. And we're going to subtract off the travel time for the torpedo. So torpedo is 100 seconds. That gives us 1.4 seconds. That is the time it takes for sound to travel. So this is the sound time to travel, and that's equal to 1.4 seconds. Cool, so now we can find out what the speed of sound is, because the speed of sound is in water is equal to the distance it traveled divided by the time that it took. The distance was 2,000 meters, and we know that it took 1.4 seconds for it to go from here, from the explosion, back to the submarine. If I divide those two, I end up with 1,429 meters per second. And that is the end of the problems.